Okay, tell me the doubt. What doubt you have in this particular
I don't
question?
understand how to solve this.
Okay. Okay. As if the linear density means, what is linear density?
Linear density is density.
Linear density is mass per unit of length. Okay?
Mass per of length.
Yeah, linear density. Yesterday we talked about surface density. So, surface density, what we were doing? We were just dividing mass by length here, as it is a linear density. Okay?
So surface density is linear density.
Surface density is, once we are talking about some area. Okay? That is lengthwise. Linear density is lengthwise.
Okay.
Okay? So, linear density will be m by length. Whatever is the mass, okay, so here linear density is given. The linear density of a rod length L varies as lambda equal to a plus bx. Determine the position of its center of mass, where x is the distance from one of its ends. So, you remember I told you the center of mass, if the linear or surface density is given, then it will be x dm. If it's a linear density, then we'll have x dm divided by integration of dm.
You never taught that.
Yeah, I told you.
We just did like something for. We did. We did something like 1 by m is equal to r dm.
So that was the same thing. Okay. Do you get it?
Okay, we will just solve it.
Okay. So if I take some small mass, let us say this is a very small mass. So in case of the small mass, the linear density, let us say the linear density will be equal to dm by, as it is a small distance, so that will be equal to dx. So in that case, your dm would be equal to linear density into dx, isn't it?
Yeah.
Okay. So the linear density is given as lambda equal to a plus bx. Okay. So dm will be what? Lambda is the linear density. So dm will be lambda into dx, isn't it? So that's why they have taken dm as lambda into dx, and lambda is given as a plus bx. So we have put at place of lambda, we have put a plus bx dx. So dm now becomes a plus bx dx, isn't it? And this is your formula of center of mass. Whenever linear density or surface density or volume density is given to you, you can go it according to this one. Okay. Got my point? Okay. Just try to find it out. Try to find it out at your own. Give it a try. Now you understood my point?
Yeah, I think. Let me try that.
Okay. Give it a try. And what is the schedule for tomorrow? I think tomorrow must be a holiday.
Yeah, tomorrow's a holiday.
I will try to have 2 to 3 sessions tomorrow. Tomorrow I want to finish your whole syllabus. The formula is xcm will be 0 to L xdm divided by 0 to L dm. Okay. Why it is taken as from 0 to L? Because it's a total length of that road. It is from 0 to L and mass is from 0 to L, the entire mass. Okay, it is not a it's not a different concept, it is the same concept. What we were doing in previous one, we were just multiplying m with x1, isn't it?
Yeah.
And we'll divide it by m, the total m1 plus m2 plus, that's all. So that was your xcm. So in this also we are doing the same thing. Okay, it is not
But we
different.
don't have the mass in this case, sir.
Yeah, but we have surface, we have linear charge density, linear density. So linear density is lambda is equal to, what is linear density? Dm by dx, isn't it?
Okay, so we can do dm by dx is equal to a plus bx, and we can find dm that.
Yeah, you just find dm and put the value of dm here. Okay? Then integrate it.
Okay.
So that is actually the same thing, but it is written in a different manner. Done?
No, sir.
You're taking
Solve it.
you're taking too much time here.
Super. I'm still not able to solve it. It's coming up with the integration coming as 0 L x a plus bx dx.
At place of dm you have put a plus bx dx. If you multiply this, so that integration becomes 0 to L ax plus bx square dx divided by 0 to L a plus bx dx, a plus bx dx, isn't it?
No.
Okay, so that becomes ax square by 2 and that becomes bx cube by 3. It is from 0 to L, isn't it? That becomes ax plus bx square by 2 and it is from 0 to L. Now put the limits. That will become al square by 2 plus bl cube by 3 minus 0.
Yeah.
That becomes al plus bl square by 2. L we can take it common. So that becomes al by 2 plus bl square by 3 and here in the bottom it becomes a plus bl by 2. Further we can simplify it by taking 2, just multiply everything by 2. So that will be al plus, okay, multiply with 6. So it becomes 3al plus 2bl square divided by 6a plus 6 plus 3bl. Okay? So that will be the answer, isn't it?
Yes.
Okay.
And sir,
Yes.
you still need to explain the uniform one, right? Center mass of uniform symmetric bodies.
Yeah, center of mass of uniform symmetric bodies, it will be very, very easy. You just need to find the line of symmetry. Okay?
Can you explain one?
Always symmetrical figure will have more than 2 line of symmetry, 2 or more than 2 line of symmetry. Okay?
Can you explain either 7, 8 or 9? Because they are all uniform.
See this one, as it is a square, so it is having a line of symmetry, this one and this one. So where these symmetries cutting each other, that will be the center of mass. But it will be in the case of a regular shape. Okay?
Can you explain for like a quarter circle or a half circle?
Yeah, it will be
Quarter
different.
ring. No, sorry, ring. Quarter ring.
Quarter, it will be different because I told you yesterday, if it is a quarter circle, then let us say this is your circle, okay, and you have taken this part away.
Okay.
So what will be the line of symmetry of this remaining part? So the line of symmetry of the remaining part will be, I told you yesterday also, that first of all you find line of symmetry of this circle, entire circle.
Okay.
So entire circle line of symmetry will be, and you just have to minus, let us say the line of symmetry of this removed particle, removed portion is x dash y dash. Okay?
Okay.
Okay, and the mass of this removed particle is, let us say, m, and the mass of the entire circle was m, and its center of mass was x and y. Got my point? So xcm, the center of mass of this body after removing this 1/4, will be equal to mx minus, let us say it is capital M. So mx minus mx dash divided by m plus m. Got it? So sorry, it will be minus, because we have removed this portion. So their moments as well as their mass will be subtracted rather than adding it.
But if mass isn't given,
Yeah, it will be given.
no, can you go to question number, explain illustration 7, 8 or 9? They are not given the mass. 7 or 8?
Okay.
7, 8, 9.
Fifth you done?
Yeah, 5th third.
So how you fifth question is done?
In 5th, they did give us a mass.
Where the mass is given?
Like, we can just take it as n, right?
Yeah, so the simple way it is, mass is not given here. Mass will be cancelled actually. Okay.
Yeah, but it's not getting cancelled for 7 or 8.
Okay. So you done with fifth?
Yeah.
Was there any issue?
Can you just explain why it will be if the mass of the small one would be m divided by 4?
Where it is? This one?
Yeah, the mass of the circle that was removed is m divided by 4.
Yeah. What is the question? Disc of radius r is cut off from a uniform thin sheet of metal. A circular hole of radius r by 2 is now cut off from the disc, with the hole being tangent to the rim of the disc. Find the distance of the center of mass from the center of original disc. Okay. So let us say mass of original uncut circle is small m. Got it? Mass of hole of negative mass will be m by 4. Why it will be m by 4?
Because like it's been cut off from its.
No, can you see the radius of this circle?
Yeah, it's r by 2.
Radius is r by 2. So how much will be the mass?
Radius is r by 2. The mass will be. We need to calculate it by this, right? First we need to find its area.
Yes.
Area would be pi r square for the bigger one.
See,
and
as this mass is cut off from the same disk, so the surface density will be the same.
Yeah.
Okay. So what is the area of entire circle? Area of entire circle is pi r square. Okay. Got it?
Yes.
What is the surface charge density? Surface density will be m by capital A, isn't it?
Yeah.
Okay. So the entire mass will be sigma A, isn't it? Entire mass will be sigma A.
How?
Mass will be equal to sigma into A.
No, why would we use the sigma formula in this case?
See, sigma will be the same, yaar. Sigma.
We use it for composite bodies, right?
So it is a composite body. We can consider it as a composite body.
Okay.
As it is a part of this circle only, this sheet only, so we can think it as a composite body, isn't it?
Okay, yes.
So mass of the entire one will be sigma pi r square, isn't it?
Yeah.
So how we are finding its mass? Mass is given by the area, isn't it?
Yeah.
So mass of this one will be again sigma and pi. What is the value of radius? Radius is r by 2. Okay. And if we make it square, it becomes sigma pi r square by 4. So that is m1, isn't it?
Yeah.
What is sigma pi r square? Sigma pi r square is small m.
Yeah.
So m1 would be small m by 4.
I don't understand it properly.
Why you are not understanding it? Surface density is m by a. Do you understand it?
Yeah, surface density is m by a.
So what is m? M is surface density into a.
Yeah.
What is area of this entire circle? Pi r square.
Yeah.
So its mass will be surface density into pi r square.
Why did you multiply it by surface density?
यार it is a formula मेरे भाई. It is a formula. Surface density is m by a.
Yeah, I understand surface density is m by a.
So m is surface density into a.
Yeah. Surface, okay, area would be pi r square. That's a surface density pi r square.
Yes.
Okay.
So now the surface density, the mass of this smaller one will be also given by surface density into pi. R by 2 is its radius.
Okay.
So it will be given by r by 2 whole square. So if we take r by 2 whole square, it becomes r square by 4.
Your voice is breaking, so I can't hear you properly.
What is the radius of the smaller circle?
R by 2.
R by 2. We have put that r by 2 here. Okay.
Yes.
So it becomes sigma pi r square by 4.
Yeah.
So sigma pi r square is what? It is m.
Yeah.
So we kept it as m. So m1 will be m by 4. Okay. So whenever mass is not given, we'll calculate it by surface density. That's why we learnt about surface density, because it is taken from the same disk. Okay.
Okay.
You understood now how it is minus m by 4?
Yeah.
Okay. Is there any doubt in this question?
No.
No. Okay. Just tell me one thing. Are you doing the question or just see the question in the book?
No, sir. I'm solving every question.
Okay. Why you solving on the book only? You just see the question and solve it on the paper, not on the book.
Okay.
Okay. Just see the question and fold it. That's all. And try to solve it at your own. Don't take help from the book. Okay?
Okay. Yeah.
Because in the test, you will feel difficulty once if you're just seeing the question and answers. Okay?
Okay.
Anything from sixth one?
No.
Okay. Okay, seventh one.
Okay, you can accept any one, either 7, 8 or 9. They're all the same, like those are my doubt.
Okay.
Then I'll try to solve the rest.
So the question is given, find coordinates of center of mass of a quarter ring of radius r placed in the first quadrant of a Cartesian coordinate system with center at origin. Okay.
Okay.
So let us say the center of mass is here. We are just considering that center of mass is here. Okay. So what will be the coordinate of this point? Coordinate of this point will be xc and yc.
Yeah.
Okay. And this one, as it is a symmetrical figure, isn't a symmetrical figure?
Yeah.
So as it is going from, it is having an angle of 90 degree. So line of symmetry will be passing through pi by 4. That means 45 degree.
Yeah.
Okay. So that will be passing through 45 degree. So that angle will be pi by 4. And this is given as the radius.
Yes.
So can you find this xc? The length that will be xc. This length will be yc.
Okay. Yeah, consider that as. Okay, understood. The question solved.
Okay.
Yeah.
Just try to solve it out.
Yes.
Use simple trigonometry. You can find the value of xc as well as the value of yc.
You multiply it with 360, right, to convert it from radians to...
Why you are converting into radian?
No, converting it from radian to degrees.
Yeah. It is written as pi by 4 because we don't write it in theta. Okay. So that's a standard representation.
Oh,
Otherwise, we need to keep the value of pi, but we avoid it. So for avoiding it, we just write it in the form of pi.
I need to do 14 to pi to solve this then.
14 to pi?
Yeah, because if I do pi by 4 into 360,
Why you are just making it complicated?
but then how will I convert it to degrees without doing that?
So you just have to multiply it by 180.
By 360, right?
180. It is,
Well,
if it is pi by 4, so at place of pi you need to put 180.
in place of pi.
Yeah.
Okay, I can just do 180 divided by 4.
Yes.
Okay, I thought it was compulsory to multiply the radian with 360 in order to solve it.
No. If you are converting it into degrees, just put at place of pi, just put at 180. So that will be given as degrees. If it is degrees, just divide it by 180, that will be converted into radian. Okay. As it is 45 degree, so just put 45 divided by 180.
But how will I get
And multiply it by pi.
Okay.
So you need to multiply pi by 180. Okay.
Okay. I will save a lot of implements. My component is equal to r by root 2.
Okay. R by root 2?
Yeah. We converted it to degrees, right?
Find coordinate of center of quartering of radius r placed in the first quadrant of a Cartesian coordinate system with center. Okay, making use of result of circular distance OC of the center of mass from the center is OC. OC will be equal to how much?
R. This will be equal to r, right?
See, OC is not equal to R because it's a circular disc. Okay.
Okay.
So the center of mass will be somewhere here. It is on the disk. Okay, it may be.
Okay.
Okay.
So we can't take OC as R like you did.
Yeah. OC is not
What
R.
are we supposed to take it as?
Making use of the result of circular arc. What is circular arc? How much is the circular arc?
We need to find that out as well.
Arc is
They gave some formulas on the earlier page. R sine theta by theta, 2r sine theta by 3 theta.
So theta will be equal to arc upon radius.
Yeah.
Theta is equal to arc upon radius. Okay. Theta is what? Theta is pi by 4.
Yeah.
Arc is how much?
We need to find out the arcs. Okay, theta is pi by 4. It will be r pi by 4.
No. What is arc?
Yeah, it will be r pi by 4, right?
Yeah. It will be r pi by 4. Just a moment. Yeah, they have given some formula about the circular disc. Okay.
Yeah, this one.
Yeah, this one. Okay. So center of mass of some uniform symmetric bodies are, if it is a semicircular ring of radius r, so that will be 2r by pi. If it is a semicircular disc, then it will be 4r by 3 pi. But we are talking about circular arc. Okay. So the center of mass will be r sine theta by theta. It is a simple formula. Okay.
So we just put it in the formula.
Yes. So xc will be r sine theta by theta. Got my point?
Yeah.
So your xc will be r is r, sine theta means sine pi by 4 and theta is pi by 4. Got it?
Okay.
So like this you need to find its center of mass. Okay.
But you need to convert pi by 4 into degrees first, right?
No. Why you need to convert it into
But
degrees?
how will we do sine pi by 4 then?
Sine pi by 4 is how much? Sine 45. Sine 45 is how much? Either you converting it, there is no issue. If it is written in radian, so answer will also be the same. If it is written in theta, if it is written in degrees, answer will not change. Okay. Sine pi by 4, or if you write it sine pi by 4, or if you write it sine 45, answer will be same. Okay.
I should remember these formulas.
Yeah,
right?
yes. So these are for special regular shapes. Okay. These are symmetrical bodies. So you need to remember it all. Yeah, in the previous session I forgotten to tell you this one. Okay. So that's why it's OC, that means center of mass would be equal to r sine pi by 4 divided by pi by 4. So that is the coordinate of center of mass. That means xc is 2r by
Okay. Okay, so I think we have to do these types of questions now.
yeah.
Let's continue.
Okay. Now in this also you need to find the center of mass. So if you have OC, OC is 2 root 2 r by pi. Okay. So this OC you have, got it?
Yeah.
So if you have this OC is what? OC is this one, 2 root 2 by pi. So that means that is OC, so that is 2 root 2 r by pi. So simply now you can find out XC. So what will be XC, the coordinate of XC?
So when we find this, what I don't understand, what are we exactly finding? So we find the distance between the origin to the center of mass.
Yeah. So that will give you the distance between center of mass and origin. But
how do we find out the x and y coordinates from it?
Yeah, we can find out.
Okay, imagine we found 2 root 2 by r, then how do we 2 root 2 r by pi? How will we find the x
Yeah.
and y coordinates?
So the cos pi by 4 is how much? Cos pi by 4 will be the adjacent upon hypotenuse, isn't it?
Yeah.
So adjacent is XC, and what is hypotenuse? 2 root 2 r by pi, isn't it? So cos pi by 4 is how much? It is 1 by root 2. Got my point? Root 2 cancelled. So now XC is 2r by pi. Okay.
Yeah.
So basically that is that formula we seen previously. That formula is giving you the distance between center of mass and the origin. Okay. So XC will be given by, XC will be 2r by pi. Now you can find out the value of YC as well. This is YC, isn't it?
Yeah.
So that will be sine theta. That means sine pi by 4 will be equal to perpendicular upon hypotenuse. So YC by 2 root 2 r by pi. Okay.
Yeah.
So just put the value of sine pi by 4. So that will also be the same. Okay.
Okay.
So that 2r by pi will be the value of YC. Got it? Okay. Now just try to find out this one. First of all, you will be finding the distance OC. Okay, just refer that formula. And in this scenario, what will happen? X will be 0
Yeah, x would be 0.
and YC will be given directly.
Yeah.
Okay. Just see what is the formula.
R sin theta by theta.
Yes.
So,
It is a circular ring, disc. Just find the value here.
yeah, 1 second. 2r by pi.
Yeah, 2r by pi. So that means that will be the y coordinate of center of mass.
Yeah.
Isn't
and
it?
x would be 0.
Yeah, x is 0. Understood now?
Yes.
Okay, just try to find it out. Now it's a uniform disk. Okay.
Should do question number 9, right?
Yes. Done.
1 second, sir.
In case of a disk, what is the formula?
I got the, yeah, 2r sin theta by 3 theta.
Yes.
And I got a value of OC as 2r into 1 by root 2 divided by 0.75 pi.
Just keep it simple, yaar. Don't divide 3 by 4. Just keep it 3 by 4 pi.
Okay.
So you found OC?
Yeah, I told you the value of OC.
Okay. Now find the center of mass coordinates.
Found it for y and it's coming as 4 by 3 divided by 3 by 4 pi. 4r divided by r by 4r divided by 3 by 4 pi.
Why it is so? See. OC is given as 4 root 2 r divided by 3 pi. Okay.
Yeah.
Now apply the same thing.
No, so I got it as 2r 1 root 2, 2r into 1 root 2 divided by 3 divided by 4 pi.
Yeah, the formula is 2r sine theta divided by 3 theta.
Yeah, I did that.
Okay, so 2r sine pi by 4 divided by 3 into pi by 4. Sine pi by 4 is 1 by root 2, so that is 3 pi by 4. Now multiply root 2 in the numerator as well as in the denominator. Okay. So that root 2 will be coming here at the bottom, so that will become simply just write it down like 2r divided by root 2 3 pi by 4. Okay. Now just multiply root 2 in numerator and denominator, so that will become 2 root 2r divided by this 2 and root 2 becomes 2 3 pi by 4. So 2 cancelled. Okay. Isn't it? Hello.
Yeah.
So that 4 will go up, 4 root 2 r by 3 pi. So that will be OC. Okay.
So, what did you do with the? Why was there root 2 left over in the third step?
Which one? You're talking about this one?
Yeah, why is there root 2 left over there? Shouldn't it be cancelled?
I have multiplied root 2 in numerator and denominator to make your denominator to rationalize it.
Yeah, there's a root
This one, 1 by root 2 on
In
the,
the numerator, there's a
see,
1 by
this 1 by root 2 will be going, root 2 will be going down.
Okay, yes. Okay.
So in the final step, we are just rationalizing it. Okay.
Yeah.
Now you have OCS 4 root 2 r by 3 pi. So again you can apply trigonometry. So sine pi by 4 is equal to, this will be yc. So sine pi by 4 equal to yc divided by this one, 4 root 2 r by 3 pi. Okay. So yc will be equal to 4 root 2 r by 3 pi into sine pi by 4. Sine pi by 4 is 1 by root 2. Root 2 cancelled. So yc will be 4 r by 3 pi. Okay. Isn't it? Similarly, your xc will also be given as 4 r by 3 pi. Got it or not?
One second, sir. Can we do it without multiplying it by root 2 as well?
Yeah, but you can't have your root 2 in denominator.
Why?
You have to rationalize it. That is a compulsory.
That's compulsory.
Yeah.
Okay.
Got it?
Yeah.
Okay, now it is now beginner box 1. You can do the questions.
Yeah, I already did it. Narrow down since
So up to which question you did?
we need to do from motion of center of mass.
Okay. So we'll do tomorrow, in tomorrow's session we'll do the center of motion of center of mass. Okay.
So, and like, how much is left? We need to do motion and center of mass. After that, we're also going to complete collision as well, right?
Yeah, conservation of linear momentum we already discussed. Have you remembered that? In NLM also we discussed this, and we also did some questions. So this part,
Okay. Linear momentum is basically
MV.
MV is MV is equal to MVI is equal to MVS, right?
Yes. So before collision and after collision momentum will be same. Okay, so that is a conservation of linear momentum. Okay,
There will
no.
also be conservation of energy inside of it, right?
Yes. We'll discuss all things tomorrow. Okay.
Okay, tomorrow what time?
Tomorrow most probably it will be 11 o'clock.
Your voice is breaking, sir. What time?
11 in the morning.